turbo engine running.
Absolute genius.
Get this.
Welcome.
This is the show where we bring you
Science.
What that essentially means is
discoveries,
Advances.
questions,
Research.
technology.
Unbelievable.
Without further ado,
This is The Naked Scientists. Hello, welcome to The Naked Scientists. This is the show that brings you the latest breakthroughs in science, technology and medicine. I'm Chris Smith. And this week we're asking whether hydrogen can meet our energy needs. With temperatures soaring in some places, our love affair with fossil fuels is going to have to come to an end pretty soon. And hydrogen is regarded by some as a very strong contender. Others, though, are less convinced. So what's the answer? Well, kicking off our investigation, here's Will Tingle.
Hydrogen, the most abundant element in the known universe, and you're probably familiar with its work in water and every molecule of every living thing ever. But in the right conditions, hydrogen is a source of renewable energy, and if it is the most common element in the universe, surely harnessing it as a fuel source sounds like a no-brainer. In fact, hydrogen-fueled projects have been in the pipeline for many decades now. The first hydrogen-powered car was the Chevrolet Electrovan made back in 1966, and hydrogen power has been in the news spotlight for every decade since.
In 2 weeks' time, this van will be the first working vehicle in the world to be sold running on hydrogen.
It may be the future of driving for all of us, and it's already here.
Buses that run on hydrogen are being introduced to try to help cut emissions in the capital. The vehicles, which cost £10 million, produce no pollution or carbon dioxide and will be on our roads by 2010.
We want to be the Klondike of carbon capture and storage, the Qatar of hydrogen. I think Qatar may already be the Qatar of hydrogen, but we want to be with you.
As the underlying technology has developed, so too have hydrogen-based projects. More recently, companies have been looking into hydrogen-powered trains. I spoke to Jochen Steinbauer, head of platform development at Siemens Mobility, about the upcoming launch of their H2 Goes Rail project, a joint venture with Deutsche Bahn which has fitted trains with hydrogen fuel cells instead of diesel engines and plans to put them on mainline railways.
At the moment, the first demonstration train is running in our Siemens-owned test center, but the first test operation on public lines with our first demonstration train will be in September in Bavaria, and this will be a really great event.
A great event, no doubt, but why did they choose hydrogen in the first place when electrically powered trains are already so widespread and proven? What advantages does hydrogen have?
The hydrogen trains, with their range of almost 1,000 kilometers, provide a certain flexibility in the operation. Comparing it to battery trains, which have a range of 80, maximum 100 kilometers, there's a certain restriction in the operation. So you have to have catenary system or special charging stations, but for the hydrogen train, you're completely flexible.
And whilst flexibility is always good with public transport, Jochen is also very impressed with how the trains themselves run.
The performance of the train is from my perspective, important. The train has 1.7 megawatt in power, and the diesel train has an average 0.6 megawatt. So we provide a higher acceleration and a higher top speed of 160. So the great advantage for even our customers is shorter traveling times and more comfort. So the potential in the hydrogen technology is huge. And therefore, I strongly believe that these hydrogen technology and hydrogen trains have a great future.
Strong words from Jochen Steinbauer there, but before we get carried away with the excitement, we should probably attempt to understand the chemistry. How does hydrogen fuel work, and where does the hydrogen come from in the first place? I spoke to the business editor of Chemistry World, Philip Broadwith.
At the moment, the vast majority of the hydrogen that we use comes from fossil fuels. In the process of refining oil and in the process of cracking to make different oil products, you can release some of that hydrogen as hydrogen gas. We can make it renewably using electricity to take water, which is hydrogen and oxygen, and electrically split that molecule apart and recombine it to make hydrogen H2 gas and oxygen.
Is that where the different terms of hydrogen come from when we speak about green hydrogen and blue hydrogen? Is that because that's the different ways in which they are made?
That's absolutely right. All the hydrogen is the same, but we classify it by where it comes from, because that has, from an environmental point of view, that has an influence on the amount of emissions that are associated with producing it. But generally, the main ones are Black or grey, which comes from fossil fuel. Blue is from fossil fuel, but with the carbon captured and stored, and green from renewable sources.
So once we've pulled our hydrogen apart one way or another, what goes on inside a hydrogen fuel cell that gives us this energy?
So a hydrogen fuel cell is basically the opposite process to the electrolysis that we were using to make the hydrogen with electricity. It takes hydrogen gas, H2, and oxygen gas, O2, recombines them in a way that generates electricity. So instead of just burning the hydrogen in air to make water, you can do the same chemical reaction, but inside a fuel cell, which allows those atoms to combine together to make water. And instead of making heat, it makes electricity. The reason it can do that is because chemical reactions involve transmitting electrons between molecules. And if instead of transmitting those electrons directly in a kind of combustion process, you transmit them in a way that makes them go around a circuit, they can produce electricity and do electrical work.
If we are using and burning hydrogen gas the same way we use natural gas, can we just send the hydrogen down the same pipes that we use to pump gas into our homes?
Well, we absolutely could. That is technically feasible. Whether we should or not is a completely different question. So it all comes down to how much energy it takes to generate the hydrogen, to transport it, and then how much energy you get out at the other end. Everybody kind of says the energy density of hydrogen is much better than the energy density of natural gas. And if you consider it by terms of weight, then yes, it is. If you consider it by terms of volume, natural gas has much more energy per unit volume. The problem with heating homes is that if you compare it to using natural gas, it's much less efficient. And if we wanted to do that with renewable hydrogen, with green hydrogen, it would take more renewable electricity than we currently generate for the whole country to heat everybody's homes using hydrogen. And partly that's because each step of the process, we lose some energy. Not all of these processes are 100% efficient. So we generate some renewable electricity. We use that to make hydrogen, which has a process of efficiency of about 80%. We might lose 20% of the energy that we'd had as electricity in making hydrogen. We then have to transport that hydrogen. That takes some energy. And then we have to burn that hydrogen in a boiler to heat water, to heat our houses. That's not a particularly efficient process.
If hydrogen can't be pumped down the same gas pipelines as the ones we were using before, how best to transport it, if at all?
The best way to transport it is a pipeline, because that doesn't require you to compress the hydrogen, which loses lots of energy. It doesn't require you to cool it or anything like that. But whether we need to transport hydrogen at all depends on what we're going to use it for. The vast majority of the hydrogen that's used at the moment, used in chemical processes, used in various things, never leaves the compound or plant where it's made. Partly that's because we're making it in places that process fossil fuels and therefore produce the hydrogen, and then it gets used in various chemical processes. But partly it's because of that difficulty in transporting hydrogen.
Phil Broadwith, ending that report by Will Tingle. Well, listening to that was Eugene McKenna, who leads the business development strategy and marketing at Johnson Matthey's Hydrogen Technologies business, which is putting a lot of weight behind the hydrogen wheel. What's the business case, in your view, for hydrogen?
So I think I'm sitting in a room at the moment, and as I look around it, almost everything in the room has been made either from the energy or the molecules in fossil fuels. And the world economy, which has, improved people's lives enormously over the last 30 years, 40 years, 50 years, all of that growth is fueled by fossil fuels. And if we look forward over the next 30 years, we've got to keep all of that economic growth, keep it going, make more people wealthier in the developing world, and do it all while stopping using fossil fuels. So that's an enormous task. It's impossible to do without hydrogen, not simply from the perspective of energy sources and energy carriers, but also from the perspective of the materials that we make the modern world from. We've got to make it again, but make it without fossil fuels.
So what technologies are you investing in or developing in order to do that?
So Johnson Matthey has a long history in this. We're a 200-year-old company. Actually, fuel cells were invented over 200 years ago, and Mr. Johnson actually helped William Grove with the first experiments with fossil fuels. So it has been a long time coming. We were also involved in the fuel cells in the Apollo landing craft. Our interest is in the smart components at the heart of the machines, electrolyzers, that will make green hydrogen from renewable electricity. We also design the technology that will enable blue hydrogen, that's making clean hydrogen from natural gas, but capturing the carbon dioxide. And we also have a chemical toolkit that will enable us to use that hydrogen not just as a fuel source, but to make the modern world around us, for example, making nitrogen, making ammonia so that we can feed the world, and making plastics. And finally, we also have an interest in that kind of reverse reaction, which is to take the hydrogen and turn it back into electricity through fuel cells to replace internal combustion engines.
One of the points made by Phil Broadwith in the piece we were just listening to was the amount of energy that you're moving when you use hydrogen compared with natural gas. The amount of energy that you're moving is very different. So is hydrogen sufficiently versatile and energy rich in order to be a substitute for natural gas, or is it just the best option we've got on the table at the moment?
So I think the key thing about hydrogen is that it doesn't contain carbon. So it's a carbon-free energy carrier. And we've got to use it where it is the best possible thing to use that does not produce greenhouse gases. So it will be essential for some of the most carbon intensive processes in the world today, such as making glass and making steel. Making steel, for example, produces far more greenhouse gases than transport in the world. So these are things that are easily forgotten. Electricity is going to be very good for many applications, such as for heating houses. I would agree it will finally be a better solution for heating houses, but only once those houses are well insulated. In the UK, for example, hydrogen has been used before for lighting and for heating when we had town gas, which was made from coal, from gasification of coal, even back in the 1960s. So the pipelines used to contain hydrogen and carbon monoxide. The interest in putting hydrogen into that network at the moment is that we can have lots of blue hydrogen very quickly. And there's got to be somewhere to put it. And it can be put into the gas network at up to 20% without changing any of the end use applications, while we wait for the hydrogen fueling networks that will use hydrogen in fuel cell cars, for example.
The thing that really people are focusing on, both in industry but also domestically, has got to be the bottom line, though. What is happening to what's in their pocket? So what are the cost implications of doing this kind of thing? What do your models suggest in terms of how big this market is and how much people are going to have to spend to do this?
So I do think it's important that people bear in mind that what we're trying to do is to fuel the modern world without destroying it. So there shouldn't be a direct comparison with the fossil fuel world. But we see huge economies of scale in manufacturing the materials that are required to go through this energy transition. And as we build out renewables, and we see huge potential to reduce costs as we drive technology forward, which is one of the great interests of Johnson Matthey. So, for example, at the moment and before gas prices increased, grey hydrogen was around $1.50 to $2 a kilogram, while green hydrogen was up to $8 a kilogram. Now, over the next 10 years, we see that cost of green hydrogen dropping down towards that $1 to $2 a kilogram level, all driven by improvements in manufacturing and reduction in costs of fossil fuels. And if we look at the United States at the moment and the regulatory environment that they have there at the moment, where they're giving $3 a kilogram for the production of clean green hydrogen, there's a regime, or a regulatory regime, which is encouraging people to invest in all aspects of the hydrogen economy so that those economies of scale can soon be realized.
What's really holding things up then? Is it just that technology is not there? Is it that the infrastructure to use hydrogen in this way is not there? Is it that the market's not there and the Americans are getting behind it because they're already a bad offender on the carbon front, so they're doing something to offset that? What are the hurdles that you need to overcome?
I think the Americans see the economy of the future and intend to win in it. I think the trickiest thing about this market is that we need everything to develop at the same time, both the production and the use. And so government needs to regulate to encourage those to happen at the same time. Also, subsidies are required at the start. Otherwise, people keep waiting for the next generation of technologies, which will be cheaper. So they need to be encouraged to buy the first generation so that the second generation will be cheaper. So get the regulation right, and market forces will drive those costs down.
I guess we'll wait and see, won't we? Eugene McKenna there from Johnson Matthey. Thanks very much indeed.
The Naked Scientists podcast is produced in association with Spitfire, cost-effective voice, internet and IP engineering services for UK businesses. Find out how Spitfire can empower your company at spitfire.co.uk.
Music in the programme is sponsored by Epidemic Sound, perfect music for audio and video productions.
This is The Naked Scientists with me, Chris Smith, and this week we are exploring what role hydrogen may or may not have in our ongoing race for renewables. Now, as we were just discussing, hydrogen isn't without its critics. And the energy consultant Catherine Porter has just penned an article on hydrogen as a fuel for the Daily Telegraph, and she's with us. Eugene was clearly a fan of hydrogen and its potential benefits, Catherine, so has he convinced you?
No, he hasn't. Obviously, he's working on hydrogen projects and wants to talk about the benefits, but it's a pretty one-sided view. For example, he mentioned that in the past we had hydrogen going through our pipes in the old days of town gas. Well, that's not completely true. That was only going through low-pressure networks locally, not through the high-pressure gas grid that we have today. And it was extremely poisonous, so it's not really a good comparator.
Well, that was the carbon monoxide, wasn't it, that was poisonous to people? I mean, just to be clear with that. One of the big problems with hydrogen, as I see it, based on what Philip Broadwith was saying, is that we lose loads of it. He was saying there are losses when you make it, there are losses when you distribute it, there are losses when you use it. It's not a case of you just put hydrogen down the same pipes that you put methane down.
That's correct. Hydrogen has a very small molecules, much smaller than methane, which is the gas that we have at the moment. And so if you try and put it down the same pipes, you're going to have more leakage. So it leaks sometimes through the pipes themselves if you've still got the old cast iron pipes, but particularly through joints. And then when it goes through meters and through appliances. The other issue you have is the way that you move gas through the pipeline system is through the use of compressors. Now, when you have a system with methane, you have losses of about 3% through those compressors. With hydrogen, it's about 10 times bigger. You lose a third of your gas just from powering those compressors. So that's a huge amount of loss that you have to accept. And then, as you mentioned earlier, you need a lot more gas to get the same energy output as well. So to have the same level of warmth in your home, you would need a much larger quantity of gas. So the amount that you'd have to put into the system at the start is so much bigger than it is at the moment with methane. And then the cost would be so much higher.
In your Daily Telegraph article, you say that hydrogen's currently a backfill technology in the sense that it's our least worst option. What exactly are you getting at with that point?
So I think the physical characteristics of hydrogen make it almost uniquely unsuitable for a lot of the applications for which it's now being developed. And the only reason really that it's being proposed, and your previous guest mentioned this, is because it can burn in the air without producing carbon dioxide. Now, interestingly, it does give off water vapor, and water vapor is also a greenhouse gas. So it's just not as good as it's being made out to be. It's just not a good material for these purposes. And if somebody came up with an alternative that had better properties, they would almost certainly jump on that instead. So there's a danger that this becomes a huge waste of effort as well, because other solutions could be developed down the line. I think particular nuclear power has a much better potential to meet a lot of the applications that we're talking about, not domestic heating other than through electrification, obviously, but a lot of the industrial applications that require high temperature heat could very well be served through nuclear power.
One has to also think about the complete life cycle, isn't it? Because as we rush towards electric cars and you throw away a perfectly good petrol or diesel car, there's the whole question of, well, how far would I have to have driven the old car before it's paid back its carbon footprint versus the same for the electric car? And the electric car has a huge carbon footprint embodied in it.
It does, yes. I mean, you have Some studies have suggested you need to drive 50,000 miles before you break even on the input energy. Back in 2013, a widely cited study showed that to make one electric car, you emit 18 times more carbon dioxide than when you're making a conventional car. Now, in the last decade, production methods have likely improved, but that's a very big gap to close. Electric cars also require a huge amount more minerals than conventional cars do, and a lot of minerals that conventional cars simply don't use at all, which are not green and clean. You look at lithium, for example. The production process of lithium creates a lot of dirty water. There are actually disputes over access to water in South America because of lithium processing. And then you have other ethical concerns like the use of child labor in the Congo for mining of cobalt. So electric cars are not clean, and I definitely don't think we should be replacing petrol and diesel cars that still have a useful life with an electric car. That type of wastefulness is not good for the environment.
Do I read you correctly then when the sort of message I'm hearing is, and you're an energy consultant after all, that just using hydrogen because we can is perhaps not the best approach, and that one of the best approaches might be to use electricity and focus on making the source of that electricity as clean and green as we can, and then adapting people's end use of the electricity, heat pumps and so on, so that that remains clean and efficient as well. Is that what you think is probably the best alternative to going down the hydrogen route?
It is, yes. I think that's the way we should be progressing, unless we can find another material that can do the job that's being proposed for hydrogen better than hydrogen can. But at the moment, that doesn't exist. We haven't really found one. And so for me, electrification and cleaning the electricity system is the best approach that we could have.
Catherine Porter, thank you very much for sharing your opinion. So does hydrogen have any part to play in our renewable future? Well, here to discuss that is Jess Ralston from the Energy and Climate Intelligence Unit. From what you've heard of the previous contributions, Jess, does hydrogen have a place in our net zero ambitions?
I think, like many things in this increasingly polarised world, I think the answer probably lies somewhere in the middle. All the experts, like the International Energy Agency, the Climate Change Committee, National Grid, and others, all think that hydrogen will be very important for sectors where there are no obvious solutions. For example, as Eugene touched on, heavy industries like steel making, for glass, ceramics, those sorts of industries. However, there are solutions already existing for some of the sectors that we've talked about, like heat pumps for heating, or electric vehicles. And I hear concerns around electric vehicles, around minerals and whatnot, but already in the UK, 1 in 3 cars sold in December was electric. So we're already seeing electric vehicles become the predominant technology for decarbonising our road transport. And I think the really key point that we might have missed in the programme so far is that we're not going to have an unlimited supply of hydrogen. We're not going to have enough to decarbonise this industry, that industry, the other industry. It's going to have to be strategically deployed so that it's deployed in the industries that need it most, which are those that are hard to decarbonise, like steel.
Yes, I think Phil Broadwith said quite poignantly at the beginning of the programme that we don't have enough renewable sources in capacity terms of green electricity to make enough green hydrogen in order to just heat people's homes, let alone feed industry.
Exactly, and there's real questions about whether there's any point of taking green electricity, using that to make hydrogen, green energy, using that to make hydrogen and then turning it back into electricity for people's homes, when we could just directly put the green electricity from wind farms into people's homes through things like heat pumps. So we've got questions about, whether it's going to be blue hydrogen, green hydrogen, turquoise hydrogen, which is one of the ones that's talked about. But I think we're going to need hydrogen, of course we are, but we've got to be strategic about where we put it.
It sounds to me that you're a bit lukewarm then, in the sense that there seems to be a lot of enthusiasm from some people. Let's go down the hydrogen route. And in fact, it's more of a horses for courses. It might have a role. It might fit with some industries, but it's certainly not a one-horse race, and we certainly shouldn't be putting all our eggs in that basket.
I think that's spot on. And I think when it comes to things like home heating, there's a lot of research out there. I think over 37 independent studies have now said, look, it's not the right place to put hydrogen. And so we should probably listen to those independent studies. And even the government has gone sort of lukewarm on hydrogen heating, cancelling a proposed trial in one location. And there's lots of residents concerned about the hydrogen heating trial in the other potential location. So I think until we see and get a clearer, firmer picture of where hydrogen is going to be most useful, and by that I mean most efficient, most cost effective and most practical, I think we'll have to wait and see where the big industries will be when it comes to hydrogen.
One of the things we haven't touched on so much is one of the things that people earmark hydrogen for, which is a useful storage vehicle for energy. Because when the sun is shining during the day and there's all this solar capacity, and we often end up with a surfeit of electricity and we don't know what to do with it in some cases, that can be used to produce green hydrogen, and that can then be used later on when the sun isn't shining. So there is that use for it, isn't there? It's not just as simple as we make some electricity and then immediately make hydrogen and then cart that off to people's homes. It's more nuanced than that.
Absolutely, it's more nuanced, and that's what the Climate Change Committee and National Grid say about hydrogen. They say it could be very useful for storing up that green electricity when we do have a surplus of offshore wind power or solar power. And actually, Centrica, who are the owners of British Gas, have already committed to turning one of their natural gas storage facilities into a hydrogen storage facility. So we've already got people talking about using this as a storage fuel, and that can help us make the most of renewables, which are going to be cheaper than the fossil fuel alternative, and probably cheaper than things like nuclear as well. So it's a way of making the best use and the most use of cheaper renewables, and that's what the experts think it could have a major role in.
So putting all this together then, what's your view, gazing in your crystal ball, of our energy future? How is all this going to fit together, and what proportion of each of the different energy provisions do you think the different things that you foresee as being important are going to be?
Well, I think it depends on what sector you're talking about, really. When it comes to our power generation, we're already getting 40% of our electricity generation from renewables, and that's only going to increase as they continue to get cheaper and they continue to get more feasible in different areas of the UK. So I think renewables are clearly going to be the leading power generator as we get to a decarbonised future. I think when it comes to things like home heating and road transport that you and I will take, I think that's probably going to be electric heat pumps, electric vehicles. But, you know, even when it comes to heavier transport like lorries, HGVs, hydrogen could have a role to play there. We're yet to see how much it's going to cost and things like that, but it could have an important role. And it could have an important role, like we discussed, in storing up our power or potentially for peaking power as well. But yeah, I think there's a range of things that hydrogen could be used for. I think the government has a role to play in setting some strategic direction. Like Eugene was talking about, the US has got big green investment packages into things like hydrogen, but much wider than hydrogen as well. And the companies that are currently in the UK or thinking about investing in the UK are looking at the US and thinking, I'm just going to invest there instead because I'm going to get more for my money. So that's something that I think industry is pretty keen for the government to replicate in the UK. But I think, yeah, if we look at what the experts are saying, hydrogen is going to have a major role, but it's going to be in specific sectors. And certainly we're not going to have an unlimited supply, so we've got to be quite clever about where we use it.
What about infrastructure? Because as we heard earlier on in the programme, it's not just as easy as chucking a new gas down old pipelines. That there's a massive cost attached to doing that, and that may be a deterrent.
Yeah, and I think Catherine mentioned as well, we've got some pipes in the UK which at the moment I don't think is suitable for hydrogen because they will allow the smaller molecules to leak out. So there's some work to be done, certainly by gas networks and others who are involved. But you will hear the gas networks telling you that it's going to be easy and it's going to be quick and it's going to be great to have hydrogen piped down, to have our heating changed to hydrogen heating. But I don't think that's going to be the case. I think that's wishful thinking on their part. And when it comes to transmission, there's a lot of work still to be done on cost and feasibility.
Jess Ralston, thank you. Well, that's where we have to leave it for this week. Do tune in next time to have your question answered. It's our Q&A. You ask the questions, we provide the answer programme. You can send those questions in now to chris@thenakedscientist.com, and the wilder and wackier, the better, as far as we're concerned. So get writing. The Naked Scientist comes to you from the University of Cambridge's Institute of Continuing Education. It's supported by Rolls-Royce. I'm Chris Smith. Thank you for listening, and until next time, goodbye.